Hello. So how many times have you built a line trace? Not actually knowing what half of it actually does or did, and the only reason you know how to build one is because you just blindly followed the tutorial. One of the many. So this video is for someone who wants to know what the hell is going on at the start of a line trace. So I'm going to try and explain. And it's actually much simpler than you'd think. Most line traces that are done in tutorials usually start with the first person camera. It's actually a pretty common way to do it and probably the closest thing to the right way to do it. And they do the obligatory get world location because that's actually something you really need. It's not too many other things around that. So you need that, and that usually just goes into the your line trace. Line trace by channel, straight into the top there. Now, the next part's the confusing bit for a lot of people. Most people just build it and don't really care how it's done or how it works, just as long as it works. But, yeah, there's two common ways that it's done. One is they get world rotation, which is sort of an older way, I believe. It's not really necessary these days, but we just do a get forward vector. That's one way to do it. The other one you can do is just go from straight from the camera and just do get forward vector. Why use two nodes when you can use one? The values that will come streaming out the yellow bits there, the vectors, they're going to be exactly the same. What those values are, that's a great question. So I'll show you. Print. Just going to set it, turn that off, set that to 0.1. And we're just going to plug that straight into string. So I'll show you. And there you have it. So what it really is it's a multiplier value depending on where you're pointing in the world, which direction relative to the world that you're pointing. It ranges from -1 to 1. So for example, if you're looking straight, flat, in a horizontal way along the along the XY plane, the Z value will be 0. If you look up all the way, it goes to 1. If you look down, it goes to -1. So if you take that as a multiplier, you can then use that to determine where your Z position is going to be a certain distance in front of you based on a distance value. Pretty interesting. And it's the same value, it's the same sort of system for X and Y, depending on which way you're looking. If you're looking all the way in the positive direction on X, it'll be nearly 1, same as going the other way, which is hard to tell which way is which. Yeah, that's -X 90, and that's positive X. That's positive Y, and that's -Y. So it's a pretty versatile little thing. Kind of handy. So that's all it does. There's no voodoo going on there. And what you get out of this is the same as this. You know, so why use two nodes when you can just use one and maintain slightly cleaner blueprints? Let's just delete that. Now the next thing they do is usually multiply this value by a certain amount, which comes to this multiplication node. I have actually seen it asked in a forum and on Facebook, is this the equivalent to doing this. So convert pin to vector and just typing 1500 in each of these. They're both the same. Just by converting that pin to a float and just typing in a number, exactly the same. It's a single number to type in rather than two. So what this will give you is a relative position to the camera where you're pointing. That's 1500 in the direction you're pointing, but it's a relative position. So that's no good for the end. So to turn it into an absolute position relative to the world location, which is what we need for the line trace, you simply take that and you add it to the relative position. So absolute position plus relative position, there you go. And there you get your perfectly valid end result. You can also, if you need to adjust, you can do things like, if you know the position of the floor, you can also break these values up and you can only feed the X and Y and then just hard set the Z value, for example. There are situations where you may want to do that. But in this case, this is exactly what's happening. So you get your multipliers that come out of there, which you then multiply by the distance, which then gives you your relative position. And then you take your relative position and then you add it to your absolute position, which is your world location, and you plug that into the end. And that is the mystery of the start of a line trace that so many people ask questions about.